Hello, today we're going to be talking about the volume of prisms and cylinders. So first, we need to know what volume is. Volume is the space inside of a three-dimensional figure. And for all of the figures that we'll be talking about today, I want you to imagine that we are, let's see, where's my highlighter? Oh, goodness. That must be a marker or something. Why is it so small? Okay. I want you to imagine that we are finding the area of the base and then kind of taking that shape and pushing it all the way through to the top of the figure. So that would account for all the space inside. So remember that the bases of a prism or a cylinder are the faces that are opposite, parallel, and congruent. So in this picture right here, this is a triangular prism. The bases are these triangles because they're opposite, parallel, and congruent. And to find the volume, you want to do the area of the base, no matter what the shape is. In this case, it's a triangle. And then multiply that times the height. So a capital B stands for the area of the base. For a cylinder, and let me try to make this bigger, the base is a circle, right? But it's the same thing. It's the area of the base times the height. So it's still area of the base times the height, but we know that the area of a circle is pi r squared. So it's really pi r squared times the height. And think of the height as the distance between the bases. Height does not necessarily mean up and down because we could easily lay that cylinder on its side and the height is still going to be the distance between the circles even though it's side to side and not up and down. So you might be thinking, why'd I skip rectangular prisms? Well, they're also base times height. All of these are the same formula. So if you want to memorize only one thing, memorize area of the base times the height. But a rectangular prism is special because the bases are rectangles, and we know that the area of a rectangle would be like length times width, or sometimes we call it base times height, but if we called this the height, then we would need to call the base length times width. So it's just multiplying these three things together. But it's still area of the base times the height, isn't it? So one mistake I see students make is for any figure, they'll just multiply the three numbers. That only works with a rectangular prism. It will not work with a triangular prism, a trapezoidal prism, a cylinder. It only works specifically with rectangular prisms. All right, now let's just jump into some examples. I'm at home, my dogs are crazy, and remember, I don't stop for anything, so if they bark, I'm going to keep going. Okay, here is a rectangular prism. So here is a case where I can do length times width times height. So I'm just doing 10 times 8 times 5. And that's going to give me 400. And it's inches cubed. So this is a new label that we're using. It literally means you could fit 400 cubes inside this figure if they were 1 inch by 1 inch by 1 inch. 5 times 8 times 10. I'm double checking all my math here. Okay, this is a triangular prism. And I know that because the bases are triangles that are opposite, parallel, and congruent. So I need to find the area of one of these triangles and then multiply it by the height, which is the distance between the triangles. So I like to start always with my formula. And then this triangle right here that we're finding the area of, the base and the height, remember, are the sides that make the right angle. So we're going to do 1/2 of the base times height because that's the triangle, and then the height of the whole thing. So I'm going to do 0.5. The base and the height are 12 and 9, and then the height of the entire figure is 7. So I can put this into my calculator, just 0.5 times 12 times 9 times 7. Remember, you are allowed to use a calculator. However, I need to see your work, and what I'm writing right now is considered the work. and this is going to be meters cubed. All right, moving right along, here I have a trapezoidal prism because the bases are trapezoids. Remember, base does not mean top and bottom. It's the sides that are opposite, parallel, and congruent. In this case, that is trapezoids. And we're still doing area of the base times the height. But the base in this case is a trapezoid. And remember, a trapezoid is the average of the bases times the height. So the bases of the trapezoid are 4 and 9. So I'm going to do 4 plus 9 divided by 2. And then the distance between those bases looks like it's 4.3. You can always tell by that right angle. Oops, I don't want to put that. That's a decimal. So let's find the area of the trapezoid. It's going to be 13 divided by 2 times 4.2, and I am using a calculator, and I get 27.3. So that's the area of the base, the area of the trapezoidal base, 27.3, and then the distance between those trapezoids is 11. So I'll multiply that times 11, and I get 300.3, and this is feet cubed. And lastly, I have a cylinder, which is basically a prism, right? Because it has bases that are opposite, parallel, and congruent. It's just that they're circles. And then my distance between the circles is the height. So I'm right now going to do the area of the base, which is 1/2 pi r, which is 8, because the diameter is 16, times the height. So in my calculator, I'm going to punch in 0.5 times 3.14 times 8 times 8 times 21. That long list is going to be my answer. So 0.5 times 3.14 times 8 times 8 times 21. And I get 2,110.08. And I'm not going to round unless the directions specifically ask me to round. All right, thanks for watching. That is volume of prisms and cylinders.